Properties of logs. Properties of logs are actually very similar to exponent rules because, of course, logs are exponents. So the first two rules here are really just about inverses. So these two are really just telling you about inverses. Remember that if we do the inverse of something, then we can undo something. Just like we add, we undo subtraction. If we divide, we undo multiplication. So here we're going to undo exponential and log. So this first one, if I have the base as b and I do the log power of it, these two b's have to be the same, and I can end up making this cancel out. So I'm going to undo the exponential. So if I have an exponential b to the log base b of 5, the answer is just going to be 5 because these two bases, the exponential and the log, are going to undo each other and leave me with just a 5. If I had 6 to the log base 6 of x plus 2, this would end up being, again, because these two bases are the same, it's going to end up just being x plus 2. And then this one is very similar, okay, because now you take the log base, if I have log base 3 of 3 to the x, if I want to undo the log, I'm going to do the exponential. So you got to have an exponential here and a log here. These two undo each other, and so I'm going to end up with just plain x. Now these other rules are very similar. Now make sure you notice that it has to be on the inside of the parentheses. Notice I have multiply on the inside, and it leads to addition. So this is just like our exponent rule. Remember when we multiplied, we changed it to addition to add the exponents. Here we're going to, if inside, it's got to be inside the parenthesis on the log, is division, and notice we changed it to subtraction. So division is going to change to subtraction. Now this one's a little bit tricky because this is the power, okay, but we did have a power to power rule, and what did we learn about the power rule? We knew that we multiplied the exponents then. So notice that what really happens is you end up multiplying by the k because the k was the exponent. So another way to think about it is you're going to multiply by the power. Or you might think of it as putting the power in front of the log. Because that's how you multiply logs. To multiply logs, you have to multiply it by that number. So now let's look at some easy ones. So again, this is an exponential and this is a log, and they both have the same base here. Remember, if the bases are the same, they undo each other. So the answer is just going to be 18. Remember that there is an understood parenthesis around the x minus 2 because it's an exponent. And again, these bases, this is a log, this is an exponential, the bases are the same, so these are going to undo each other, cancel out, and I'm left with just x minus 2. You could also think of this as moving the x minus 2 to the front. Remember, the exponent moves to the front, and then I have log base 3 of 3, and there's a parenthesis around my x minus 2. And then remember what we've already learned. We can evaluate this. 3 to the what power gives me 3. 1, right? So this whole thing becomes 1, so that's why it ends up going away. So it's because we're doing the inverse, but understand that's what we were doing when we were calculating our logs. Now if it's an ln, remember that the base is understood to be an e, but we still have matching bases, so this is just going to be 3t. Similar here, we've got again just the base of e here. The e's are the same, so you just get t squared. Now we're going to expand. Now expanding basically means you're going to write it as multiple logs. And I'm going to start off by doing it really easy by just doing one rule at a time. So notice that what's inside here, remember it's what's inside the parenthesis that we're expanding. So there's multiplication, so I'm going to change it to addition. So I'm going to rewrite this as log base 4 of 5 plus log base 4 of x. And then you always want to ask yourself, can I do anything else here? No. So I'm done. So the next one, I look at this one, and again, I look inside the parentheses, and I see they're doing division. So I'm going to think division changes to subtraction. So I'm going to do ln of 6 minus the ln of x. Now notice here on multiplication, the order of these two logs really doesn't matter. But when I have subtraction, the order here matters. I have to make sure that the numerator is first and that the denominator is second. Okay, this one I have an exponent, so I'm going to multiply. So I'm going to move it to the front. So it just becomes 3 log of x. And as you can probably guess, those are all easy because they're just one rule. So when this gets harder is when I start putting multiple rules in. So I'm going to do every single step here just so that you understand step by step what to do. So when I look inside here, I ask myself, what is the big picture? And I'm going to say the big picture here is division. So what am I going to change it to? I'm going to change it to subtraction. So I'm going to have the log of 8x cubed and then minus the log of my 5y squared. But of course this isn't done, so now I'm going to go look at this one and I'm going to say, okay, what's still inside this parenthesis? It's multiplication. So I'm going to rewrite it as addition. So the log of 8 plus the log of x to the third power. And then I'm going to look at this one and say, well, here's a power. So what do I do with powers? Oh, I move them to the front. So I'm going to get minus 2 log so that I'm multiplying by the 2. So now I look and say, am I done? Well, log of 8, I can't do anything with that, so that must be done. And then plus, I have an exponent or a power here, so power means multiply, so I'm going to put it in the front. So 3 log of x. And then I've got minus 2, and then I say, well, what's here? Well, there's still multiplication. Now you have to be careful here, because I have to make sure I put a parenthesis. So I'm going to end up with the log of 5 plus the log of y. Or another way you could think about it is when you're looking at it, realize that what really happens is the ones that are on the bottom end up becoming negative. Because another way I could write this answer is log of 8 plus 3 log of x minus 2 log of 5 minus 2 log of y. Now why is that equivalent? Because I've distributed the negative 2 to each thing. Okay, that's why that's equivalent. So another way you can think about it is notice that the things that were on the numerator, I ended up adding, and the things that were on the denominator, I ended up subtracting. Now make sure that you're careful with these exponents, because notice the 3 is only on the x, it's not on the 8. So I have to put the 3 only in front of the log of x, not in front of the log of 8. So either one of these is acceptable. Okay, the next one, again, we've got multiplication in here, so I'm going to change it to addition. So it's going to be the ln of 3 plus the ln of e. And then you have to ask yourself, is that done? Is there anything else I can do? Well, remember there's a base of e here, so what's going to happen to these is they're going to cancel out. So my final answer will be ln of 3 plus 1. So whenever you think you're done, go back and check. Make sure there isn't something else you could do. Okay, this one inside I've got multiplication, so I'm going to rewrite it as addition. So the ln of x plus the ln of the square root of 1 plus x squared. So there's nothing I can do with the ln of x, but I could rewrite the square root as a power, right? So I could write it as 1 plus x squared. And remember, square root means the half power. So now I'm going to move the power to the front so I can multiply. So 1/2 the ln of 1 plus x squared. Remember that there's not a rule if I have addition in here. We only have a rule if there's multiplication in here, or a rule if there's there's only multiplication or division rules. There's no addition, there's no subtraction rules. Next one, I'm going to rewrite this with changing this cube root to an exponent. So I'm going to have the log, and then I'm going to put all of this in a parenthesis, 2x squared over y to the third. And of course the power is 1, so the exponent is going to be 1/3. So what's going to happen to the 1/3 is it's going to move to the front so that I can multiply. And I'm going to put it in the front of everything. So I'm going to leave it as parenthesis. And then I'm going to put the log, and this is going to end up multiplying. So it's going to be the log of 2 plus the log of x squared. And then this is on the bottom, so I'm going to subtract the log of y cubed. Now I'm just going to move my exponents to the front. So 1/3 log of 2 plus 2 log of x minus 3 log of y. And I could leave my answer like that, or I could distribute the 1/3 and get 1/3 log of 2 plus 2/3 log of x minus the log of y. So let's go the other way now. Condensing is just the opposite. We're trying to write it now as just one log. So I'm going to rewrite the log word with its base, and then I say it's addition. So I'm going to rewrite it as multiplication. So inside I'm going to put 6 times 10. So I'm going to get the log base 2 of 60. This one, I've got the ln, and what is subtraction. So inside here, I'm going to divide 50 divided by 25 equals the ln of 2. I got a 2 in the front, so I'm going to move it and make it the power. So I'm going to get the log base 2 of 3 squared. And make sure you simplify it as far as you can. So I'm going to leave it as the log base 2 of 9. To make it a little bit more complicated. So I look at the base. First I write down my base. I write down the log and my base. So I'm going to put log base 2 because you can only write the log word once. And then I say, well, what's the big idea here? It's subtraction. So I'm going to rewrite what's going to go inside here is going to be a division problem. The numerator is just a 48. There's nothing else to do with it. Here I'm going to move the 1/3 and make it an exponent. So I'm going to end up with 27 to the 1/3 power. So I have log base 2 of 48. But what does the 1/3 power mean? It means the cube root of 27. But of course that's not done. So I can do log base 2 of 48. And I ask myself, what is the cube root of 27? Is 3. So I end up with log base 2 of 16. And then I'm still not sure, am I really done? So I ask myself, 2 to the what power equals 16? And I can see that it's going to end up being 4. So this whole thing actually simplifies just into a plain 4.